Yesterday, at 6:46 a.m. local time in the morning, a strong magnitude 6.3 earthquake struck just offshore of San Vicente in Ecuador. As the ground rapidly shook for multiple seconds, numerous power outages were triggered, more than 150 structures were destroyed via multiple collapses, and partial collapses or some form of damage occurred to at least another 600 structures. While 30 people were injured, despite what the USGS model suggests, and this is good news, there were no fatalities. Before I discuss why this earthquake occurred and why it was seemingly more damaging than essentially the same magnitude earthquake in Turkey earlier this week, I will rapid-fire answer common questions. Is this a precursor to a larger earthquake? Probably not. Only about 5% of earthquakes worldwide are foreshocks, and the associated fault which ruptured has experienced multiple magnitude 6 and 7 earthquakes since the beginning of the 20th century, so a larger quake there anytime soon seems unlikely, while technically possible. Will this trigger a volcanic eruption or volcanic activity at one of Ecuador's many volcanoes? Almost certainly not, as volcanoes need to experience at least MMI5 or greater shaking to theoretically have a chance of activating a volcano already close to producing an eruption. The strongest shaking this earthquake produced at an active volcano was MMI 3.5 at the Quicocha volcano. Was this related to the larger 2023 Guayas earthquake to the south? Nope, that involved a different plate boundary, fault type, and struck at deeper depths. Yesterday's earthquake occurred on the zone marking the boundary between two tectonic plates. As to the west of northern Ecuador, the Nazca plate is subducting underneath the North Andes plate. Over time, stress built on the North Andes plate due to friction from the subducting plate pulling it downwards into the mantle. This stress built up until it overcame the friction being applied to it, causing what was likely around a 20-kilometer long portion of the North Andes plate to snap back upwards. This seemingly generated a minor tsunami, although I have a hunch that some yet undetected submarine landslide due to the Megathrust zone quake generated the maximum wave heights of 58 centimeters or 22.8 inches. The moment tensor of this quake perfectly matches the megathrust nature of other regional major earthquakes such as in 1906, 1952, 1958, and 1979, which, along with yesterday's event, all had a minor oblique component to them. So, why was damage seemingly more severe in Ecuador than the magnitude 6.2 earthquake that struck Turkey on Wednesday, despite the strongest shaking in a populated area experienced being an MMI 6.5? The answer revolves around multiple factors. First off, while on paper a 0.1 magnitude difference might not sound like a lot, the reality is the opposite. Compared to a magnitude 6.2, a magnitude 6.3 earthquake is 25.8% bigger and 41.2% stronger. Also, note the most common building materials in each affected city. In Esmeraldas, Ecuador, this is brick, and in Corlu, Turkey, reinforced concrete is most common. Brick is one of the worst common materials when it comes to withstanding earthquake damage, largely due to its lack of flexibility. On the other hand, concrete, while not perfect, is a bit better and has an even stronger track record when it is reinforced. And that is why Ecuador saw more than 100 structures collapse, while Turkey only saw one structural collapse from an earthquake that essentially had the same magnitude. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.